students, and welcome back to our next module of 3D geometry. Now here we have something interesting. We will try to find angle between two lines, but this time both the lines are in three-dimensional system. Alright, let us try to find angle between two lines. In angle between two lines, students, let us assume that when direction cosines of both the lines are given. Okay, so here we start. Let's consider two lines A and B. So here is a line A and there is another line B. Now we need to find angle between these two lines. So here we say let L1, M1 and N1 be direction cosines of first line. So let us say for line A, L1, M1, N1 are direction cosines. Similarly, L2, M2, N2 are direction cosines of line B. Fine. So from direction cosines of a line, we can get a unit vector along that line. Do we know this? Yes, we have seen this in previous module. So let us assume that P cap and Q cap are unit vectors along both the lines. So if I need unit vector along first line, that is line A, we say P cap is equal to L1 I cap plus M1 J cap plus N1 K cap. Remember, L1, M1, N1 are direction cosines. Right? Similarly, we can get for line B, Q cap is L2 I cap plus M2 J cap plus N2 K cap. So now we have two unit vectors along the lines, right students? Now if we want to find angle between lines A and B, let us call this angle as theta. So we are interested to find theta. Angle between lines A and B is same as angle between unit vectors P cap and Q cap. Can we say that? Yeah. And to find angle between vectors or unit vectors, we take dot product, students, right? So here we say P cap dot Q cap. P cap dot Q cap will be magnitude of P cap, magnitude of Q cap into cos theta, right? Now once we have P cap and Q cap values as we calculated, the dot product will be L1 L2 plus M1 M2 plus N1 N2, and right hand side magnitude of P cap is 1, magnitude of Q cap is 1, and then cos theta. Right? So here we get expression for cos theta as L1 L2 plus M1 M2 plus N1 N2. Now students, we put this expression under modulus because we say here in this formula theta is acute angle between the lines A and B. Alright students, so this expression or this formula is very much useful in our problems to find angle. Right? Now let us consider another scenario. We need to find angle between two lines, but this time we have direction ratios of the line. Okay, let us proceed. Let's consider two lines A and B. So here we have a line A and line B. Now let A1, B1, C1 be direction ratios of first line and A2, B2, C2 be direction ratios of second line. So students, once we have direction ratios of a line, we get vector along that line. So here we say first P bar and Q bar be the vectors along two lines. So for a line A, the vector along that line will be P bar is A1 I cap plus B1 J cap plus C1 K cap. Similarly, for line B, the vector along the line is Q bar equals to A2 I cap plus B2 J cap plus C2 K cap. Fine. Now students, once we have vectors, we proceed in a similar way. We say, let's try to find angle between lines A and B. Let us assume it as theta. Now, angle between the lines will be same as angle between the vectors P bar and Q bar. And to find angle between the vectors, we take dot product of vectors, right? So let us consider P bar dot Q bar. Now this will become magnitude of P bar, magnitude of Q bar into cos theta. Now P bar dot Q bar can be obtained using P bar and Q bar values. It will become A1 A2 plus B1 B2 plus C1 C2. And magnitude of P bar will be square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square, that is magnitude of Q bar into cos theta. So students, here we get cos theta as A1 A2 plus B1 B2 plus C1 C2 divided by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So this expression gives again angle between two lines, but this time in terms of ABC, that is direction ratios. Fine students, again we put this expression in mod because we say here theta is acute angle between the lines A and B. So whenever we need acute angle, we put it in mod. Fine students, so here we saw in this module how to calculate angle between two lines in two methods. Alright, thank you.